Okay, so day 2 of Unit 9, we're talking about translations. Okay, so a translation is a transformation that maps all points of a figure in the same distance in the same directions. A translation is a rigid motion, which is an isometry, with the following properties. Okay, so the distance from the preimage A to A prime is the same as the distance from the image B, preimage B to the image B prime, and the same distance from the preimage C to the image C prime. So all these distances are the same. So when you translate something, you slide it. So the sliding, when you slide the object, all the points are going to be the same distance apart from the original. Okay, so we also know that AB, we know that isometries preserve distance. So we know that segment AB here is going to be the same thing as A prime B prime, as well as BC will be the same as B prime C prime, and AC will also be the same as A prime C prime. We also know that isometries preserve angle measurements. So we know the measure of angle A is equal to the measure of angle A prime. The measure of angle B will be equal to the measure of angle B prime. And the measure of angle C will be equal to the measure of angle C prime. Okay, so let's describe these translations that are going on here. Now remember, these are just slides. So if we're looking down here at the preimage, which is the blue image here, triangle ABC, okay, the translation, after the transformation of the translation, you look at triangle A prime, B prime, C prime. Was this a horizontal shift? Was it a vertical shift, or was it both? It was a horizontal shift left 3 units. So we took ABC, or look at point C here. We went over 1, 2, 3, went to the left, and then we went up. We went up 1, 2, 3, 4. So there was also a vertical shift up 4 units. Okay. So in which quadrant or quadrants is the preimage? Okay, triangle ABC. Remember, this is quadrant 1 here. This is 2, this is 3, and this is 4. So your preimage here is in both quadrants 3 and 4. Okay, what about the image? It is in quadrant 2. Okay, pause the video to describe the translation that happened in number 2. Okay, so your preimage, your original figure here, RUST, RUTS, all right, was slid this way. Okay, it had a horizontal shift to the right by, let's see, 1, 2, 3, 4. Right, so there was a horizontal shift to the right 4 units, and then it got shifted down 1, 2. Okay, so it was a vertical shift down 2 units. Okay, so in which quadrants is the preimage? Quadrants 2 and 3. And then the image is in quadrants 1 and 4. Okay, let's look at these questions that are over here on the left. I want you to pause the video, think about these questions, and answer each one of them. Would a horizontal shift to the right be positive or negative? So if you're taking your preimage and you're shifting it to the right, the x values are going to the right, that would have to be a positive. So if you're doing a horizontal shift to the left, that means your x values you would have to subtract. So that would be negative. If you have a vertical shift up, so you take your pre-image and you shift it up, the y values will be getting larger, so it's going to be positive. And then if you take your pre-image and you shift it down, well, then your y values will be getting smaller, so that will be negative. Okay? All right, another way to describe a translation is by using a vector, which is a quantity that has both direction and magnitude, which is size, and is represented by an arrow drawn between 2 points. Okay, this right here is an example of a vector. The starting point is called the initial point, and the ending point is the terminal point. So if you're looking at this diagram right here, all right, the initial point where it starts is point P, and the terminal point is point Q. And when you name a vector, I know I have it written over here, but you would name it with its initial point first, then its terminal point, with the symbol for vector over it, which looks like half an arrow. Okay, so if you're looking at this vector, from P to Q, the horizontal component you'd count from the initial to terminal, so you go 1, 2, 3, 4. So the horizontal component of vector PQ is 4. The vertical component, you'd go up from P, so 1, 2, 3, is 3. Okay, so there's a special way to write a vector, and it's called the component form. It combines the horizontal and vertical components. So if we're looking at this right here, vector PQ, you would write it in these pointy brackets. The horizontal component would come first, so the first number would be 4. The second number was the vertical component, would be 3. Okay, so let's look at these right here. It says name each vector and write its component form. So let's do number 1 together. All right, so looking at number 1, the initial point is M, and the terminal point is A. So this is vector MA with a little half arrow over it. Okay, and the component form, you're going to put in these little pointy brackets. The first number will be the horizontal component. So from initial to terminal, we'll go over to, it's going to the right. So be positive. 1, 2, 3. That's number 3. All right, and then you're going up, so that also will be positive. So it's 1, 2, 3, 4. Okay, pause the video here and do numbers 2 and 3 by yourself, and then unpause the video to see the answers. Okay, so looking at number 2, the initial point is R, and the terminal point is P. So this is vector RP. The component form of this vector, there is no horizontal component. It's not going left or right, so that will be 0. All right, the vertical component is going up, so that will be positive. So it's going to be 1, 2, 3. Okay, I'm looking at number 3. The initial point is S. The terminal point is B. So this is vector SB. Okay, component form, again in our pointy brackets here. Okay, so this time though, the horizontal component is going to the left, so that will be negative. So it's 1, 2, 3, 4, so that is -4. But the vertical component is going up, so that will be positive. So 1, 2, 3, 4. So how we're going to use these vectors to do translations is I will say, okay, here's an object. I want you to use this vector to slide it this far and in this direction. Let's look at a GeoGebra activity. Maybe. There we go. Okay. So looking at this, all right, you can do a horizontal translation. We'll look at that first. That means we're just going to slide it to the left or to the right. Okay, so if we took the original one and we slide it to the right 7 units, this over here will be our image. Okay, we go back to the beginning here. We could also slide it to, let me go out a little bit. we can slide it to the left. Okay. We can also do vertical translations. Okay. So if we slide it at the original starting spot here, all right, and we want to go up, our vertical shift is positive. Okay, let's go back to our starting point. But if we want to go down, our vertical shift is going to be negative. You can see that number right here. Okay, so let's talk about how you would use a vector. So here's our image, our pre-image rather. Okay, so, and here's our vector right here. I can change this and it's going to move our original image however I change it. So let's look at this vector right here. All right, this vector, the horizontal component is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that's going to be positive because it's going to the right. And then it goes up 1, 2, 3, 4, 5. So what we did was it took this and we moved it up. Well, we moved it to the right, 9, and then we moved it up 5 units. And that's how a vector works. I can change this to go this way. Let's see. Okay, so here, our horizontal component, you're moving it over 4, but then, which would be positive, but then you're moving it down, 1, 2, 3. Okay, so we did a right shift and a down shift to get this. And that's how a vector works. You're going to use the horizontal and vertical component of a vector to translate the image. So let's go back to the notes. Okay, so looking at this, it says sketch the figure with the given vertices. Use the vector to translate the figure. So looking at number 1, okay, so we have triangle ABC. All right, A is at 3, -3, so I'm just going to draw the triangle first. So 1, 2, 3, 1, 2, 3. All right, that is point A. All right, point B is at 1, -1, right here. That is point B. All right, point C is at 3, +3. So 1, 2, 3 is right here. Okay, I'm just going to roughly draw the sides here. All right, so there's our triangle. We're going to slide it using this vector GH, and we're going to slide it to the right 4. I'm sorry, that needs to be a negative. Let's make that a negative. We're going to slide it to the left 4 and up 2. Okay, so I'm going to take each point and I'm going to slide it to the left 4 and up 2. So let's start with A. We'll go over to the left 4, 1, 2, 3, 4, and then up 2, 1, 2. All right, so A will be at 1, -1. I'm going to write that down. So A prime will be at -1, -1. Okay, let's look at B. Let's slide it to the left 4 and then up 2. 1, 2, 3, 4, up 1, 2. So it'll be right here. It'll be at -3, 1. So this right here was A prime. This is B prime. So let's look at what C prime is going to be. All right, we're going to shift to the left 4, 1, 2, 3, 4, and then shift up 2, 1, 2. Okay, so C prime is going to be at -1, 5. Okay, and I'm just going to draw in my diagram right here. Okay, so there's the translation. Okay, so for this one, all we did was we subtracted 4 from the horizontal value, that's right, and then we added 2 to the vertical value, which was y. So our A prime was at -1, -1. B prime was at -3, 1. And then we had C prime, which was at -1, 5. So basically, if you look at this, we took the horizontal component 3 for A. All right, we took 3, subtract 4, and we were at -1. We took the vertical component -3, added 2, which put us at -1. Did the same thing for B. B was horizontal component X was 1 minus 4 is -3. y was -1, plus 2, which was 1. Looking at point C, x was 3, minus 4 gave us -1, and then y was 3, plus 2 gave us 5. All right, pause the video here and do number 2. Okay, so for number 2, g is at -3, 5. Oops, wrong color. All right, so g is at -3, 5. Okay, h is at 0, 3. Okay, j is at 1, 3. All right, and k is at 3, -2. Okay, I'm just going to ever so delicately here draw this. So basically, it looks like that. I forgot to label k. So now what we're going to do is we're going to take our vector and we're going to slide it to the right, and we're going to slide this shape to the right 2 and down 3. Okay, so when we do that, we will get g prime will be at -1, +2. All right, so g prime will be at -1, +2. All right, h prime is going to be at 2, 0. All right, so 2, 0 will be right there. All right, and then j prime is going to be at 3, 0, which is 1, 2, 3 right there beside h prime. All right, and then k prime is going to be at 5, -5. Okay, so 3, 4, 5, 1, 2, 3, 4 right here. Okay, so there, I'm not going to be able to draw this one. All right, there is the translation. There we go. Okay, all right, so for number 2, all we did was we added 2 to the x value and subtracted 3 from the y value for each of the original points to get our image. Okay, so that wraps up translations, which are just slides. The next video, the day 3, will be on reflections.